Hi everyone, welcome to this week's module, week number 5. And so a bit of housekeeping. We have an assignment this week, and we will, from this point onwards, always have an assignment. So we can always have that to look forward to with more or less the same deadlines until we get to the final set of assignments where you might be given a few extra days, 1 or 2 extra days per assignment, since those assignments will ask for a little bit more content. This week's topic is using what we call the recycler view. And we're going to take a similar approach to what we've done with previous views, which is we'll talk about how the view draws itself, and we'll talk about how the view responds to events, to user events. Now, the job of the recycler view is more or less what the adapter view does, or it behaves in a similar fashion to the way the adapter view behaves. Before, in the earlier days of Android, we really had 3 major adapter views. We had the spinner, the list view, and what we call a grid view. Today, the only surviving adapter view is the spinner. The other 2, the grid view and the list view, are in the framework, but they are deprecated, which means their use is not recommended, and in fact, their use is discouraged. And you should really only come across those components in legacy code. Now, the motivation, and you'll see a lot of this talked about in the video, but the motivation for the recycler view, its reason for existing, could pretty much be summed up, and this might be apocryphal, but my understanding is, as we talked about when we were looking at building custom adapters, we had this process of implementing a recycler pattern in our getView function, which you might have seen is pretty easy to ignore. So basically, you have a function that is supposed to implement or should be implemented in a particular way, which was more work, more effort, more code, but it was very easy to not do it. There was no enforcement in the framework requiring you to implement the recycler pattern. What that could mean potentially is that you would have, for a large data set for which we're generating views to be displayed in an adapter view, you would have a lot of different views being generated. So a collection with 1,000 elements might have 1,000 views generated, or more as the user scrolls back and forth, let us say in a list view or a grid view. And if the recycler pattern was not implemented, then a new view had to be created every time. Now, the inevitable result of this would be that the user would notice some amount of stuttering or slowdown in the user interface, which they may in turn, especially if this is something they see often enough across enough applications, that may just leave the user with an impression of the platform being slow. And I guess to some degree that would be true, since this behavior that they're now experiencing is coming with this stutter. So because the recycle pattern was not enforceable with the standard custom adapters that programmers would create, the recycler view was introduced to sort of force our hand. So the idea of recycling is no longer handled in a single function where the framework just sort of expects you to do it. Instead, it now separates this idea of creating a view versus setting the properties of those views. It breaks them up across multiple functions and introduces a new pattern called the handler pattern. All of those things will be discussed in the videos. But the goal there is that because the roles of creating views and I don't want to say initializing the views. We think of initializing as being the first time we set properties, but setting the properties for those views. If we separate those 2 roles, now we no longer have the decision. It's no longer on us as programmers to decide when we recycle or when we don't, or if we recycle. The framework now handles that in the background. Now, this handler pattern comes with a lot of overhead. There's a lot of boilerplate functionality. For the most part, for most implementations, it comes across as relatively boilerplate, but we still want to understand that. And in order to fully appreciate and understand how the recycler view is implemented, we are also going to look at a separate support topic called generics. So this is a feature that exists in Kotlin. It exists in Java. You might have come across this in other languages. So we'll talk about that a little bit as well. So there's a lot to be discussed, a lot to absorb. You may want to watch these videos more than once, which really means watching early. Give yourself some time to absorb it. Follow along. Try to create these apps yourself. Modify things, change things, see the effects they have, and send an email if when you run into any issues, or schedule some time during office hours to discuss it. But we want to make sure that we wrap our heads around this. So we don't have a quiz this week, so that's one less thing to think about. Yeah, that's pretty much it. We will just want to make sure that this module, we have a solid appreciation of the recycler view, because it is now prolific. Yeah, as I mentioned, it now takes, as I did not mention, but it now takes the role of the list view and the grid view, which have been deprecated. The spinner still exists. The reason the spinner exists, I imagine, and there is no forced recycle pattern implementation of that, is usually we are not displaying that many elements in a spinner. So I guess it's, if you're displaying 5 or 10 elements, it's not really a big deal if you are properly implementing the recycle pattern or not. But when it comes to displaying large lists, which is what we tend to do in list views and the grid view, recycling is important. And now we have the recycler view to sort of make sure that it happens. So that's what we'll be covering this week, and good luck.